Good afternoon. My name is Kevin Farley. I'm here with Kun Chung and Alex Shibo. We're here to talk about Graph. So I'd like to do a little bit of survey of the room. How many people have heard about Graph? Good. How many people have used Graph, even playing with it? Just a few. Okay, excellent. So we're here to talk about the Graph extensions in Microsoft SQL Server 2017 and also Azure SQL Database. It's live in both places as of Monday, I guess. Live in Azure SQL Database now. Hang on. Minor technical difficulty. Okay, that's better. So, talking about the themes in SQL Server 2017, and those are also themes we use when we're developing Azure SQL Database because it's all the same code base. So you'll see features in both places as of the next release. You'll see features light up in Azure SQL Database about once a month. We drop bits into Azure, and about once a year we'll deliver them to you on premise. So the themes for the 2017 cycle have been adaptability. So adapting based on workload characteristics, observed behaviors. We're doing a lot of work inside the query engine to look at what's happening in the execution of a query and adapt to it either on the fly within the execution of the query or for the next time. Memory grant feedback. So if we grant a set of memory for a query, if we find out at the end of the query that we granted way too much memory, we didn't use much of it, then we'll remember that and the next time we'll grant less so we don't starve other queries. Conversely, if we spilled to tempdb because we didn't have enough memory on hand, we'll remember that and allocate more the next time. So there's a bunch of different features like that that we're doing to help queries get faster and adapt on the fly. It's the coolest kind of feature from my standpoint, although it's hard to talk about because there's no surface area, there's no flashy stuff. It just, you install a new version and it runs faster. And for me, that's the best kind of enhancement for you guys because you don't have to do anything to get the benefit, just upgrade. Choice. You've been hearing a lot about choice this week. So this is about being able to reason over any data on any platform, using any language, anywhere. So all of these dimensions of choice is what we've been trying to provide in this release. So this is providing bridges out to Hadoop data, different kinds of data you can access through T-SQL, standard T-SQL. You don't need to learn a different kind of querying. Being able to deploy on Linux, using Docker containers, in the cloud, on-premise, all the same functionality. So it's all about giving you the choice for where you want to run your applications, how you want to deploy them, what languages you want to use, rather than forcing you to come to a constraint set that this is what we give you, you have to work with this. We're coming to you. Mindshare. Microsoft in general, but specifically the SQL team, has long worked with our community partners and community organizations. The SQL Pass organization is one of them we worked out with, obviously a great deal. And we gain a lot from that, those community engagements. We gain a lot from listening to you guys, and hopefully we contribute to you. As we've brought on new areas of technology, we're joining in with the Graph community, with the various Linux communities, so we're also engaging in those communities. We're engaging in open source projects as well, contributing. So we're making a big effort to take advantage of and to provide good stuff to the community. So our talk, we're going to center our talk around a scenario because it's a lot easier to make it concrete if we've got a specific example that we can talk through and go through end to end. And the example that we thought would be appropriate is a second session recommendation scenario. So when you choose a session, you may get recommendations for what other sessions you might like. And that's the scenario we're talking through here and how you might implement that using regular T-SQL and what it would look like in a graph and why graph might help you in that scenario. So we have attendees. Not much of a conference without attendees. Attendees have connections to their industry and their location that they're from, right? Speakers. Speakers are also from a location and associated with an industry, and hopefully one or two of you might follow the speakers. That would be cool. And attendees attend sessions. Speaker presents sessions. And the session has topic and track. So there's all these relationships between these entities. You have speakers, attendees, industries, location, sessions, topics, tracks, all these different entities, and there's relationships between them that can provide a very rich picture. So we're going to talk about how we can leverage that and how Graph can help you with that. So making session recommendations, you can do this with a relational database, right? We're relational. Why do we need anything else? So this is, you find the Graph session up at the top, identify other users who attended the Graph session. So you went to the Graph session. Who else went to the Graph session? So that's the first section. And then you find other session that those users attended. So you go a couple hops. And then you sort by the number of people that recommended each session and present that top 10 of that list. So you can do all that. It's a bunch of joins, a bunch of group bys, fair bit of T-SQL. It can be done. But again, it's not really obvious code. You have to kind of parse through it to figure out what it's doing if there weren't handy green comments there. But the other thing about this is that it's not really flexible. Say that we wanted to make the recommendations a little more intelligent. So maybe we want to take into account industry. So let's weight more heavily the recommendations of people that are in the same industry or related industries. Well, you'd have to rewrite that whole query pretty much to add that extra piece in. So it's not as flexible as we might like. So let's see if there's another way we can approach the problem. So we're talking about graphs, right? Well, what is a graph? Does anybody who here knows what graphs are, other than what's on the slide? Okay, so graphs are a collection of nodes and edges. Okay, that doesn't tell me much. What's a node and an edge? So nodes are the entities in your picture. So nodes are the location, the speaker, the session, the presenter. All these things are nodes. And those nodes have properties. So attendees have names. Attendees have addresses. All these things. Locations have names. All these entities, these nodes have properties. Edges are the relationships between those nodes. So this is the common terminology used in the graph world. So mostly they connect different entities together. And in graphs, a given edge may not have, it's about the relationship, really. It's not a specific connector between two specific nodes. So I might be from Seattle and from the computer industry. Both of those connections use the from edge, but it's a relationship between a person and something that is their attributes. Edges may or may not have attributes. So you may have an edge that's just serves the purpose of connecting two nodes, or you may have an edge that contains other information along with it. So the attends edge may have your rating of the session, which is obviously in the top, right? So an edge, when you attended a session, may carry other information or not. So that's kind of the vocabulary we use within the graphs. So what's a graph database? Edges or relationships are first-class entities in a graph database. They can have properties, attributes associated with them. A single edge can flexibly connect multiple nodes within the graph. So Bob is from Orlando and from the insurance industry. He attends the keynote, he attends SQL Graph. You can express pattern matching and multi-hop navigations very easily. So this is where graphs shine. It's being able to express those relationships very concisely and very intuitively. But it also supports OLTP and OLAP analytics, just like SQL database, because, hey, it is a SQL database, right? And this is where we think we have a distinction between our implementation and a lot of other graphs out there, because we're within the context of the SQL database ecosystem, which is a very rich ecosystem. So why would you use graph databases? What are the use cases? They're very useful for connecting hierarchical, interconnected data. So you may have this that looks like a straight hierarchy, but there's exceptions where someone may have multiple parents in the reporting structure. So there's a dotted line reporting there from Mary to Natalie, where she would normally report up through Jerry and Jacob. So it's a very complex set of relationships there, and graphs are good at managing that. Complex many-to-many relationships. So one relation, one edge, can very flexibly connect multiple different entities. And here you see the froms from industry and location. The speaker there's a relationship between location and speaker, and location and attendee. I need to slow down. So graphs are very good at expressing complex relationships. And analyzing the interconnected data. So you can materialize new information from existing facts. You can identify non-obvious connections. So you may find out that there are a bunch of attendees that tend to go to the same track of sessions, but you can look at the different pieces of relationship we've got recorded here and maybe come up with some new insights in terms of what industries tend to be interested in what topics. Is there a relationship there? Can we find correlations? We do machine learning to find out those different inferences, what conferences different industries tend to attend, and we can then react to that. So there's a lot of different ways that have been used to approach creating graph databases. And using this, I'm going to describe what our thinking was behind the strategies that we chose. We're working within the context of SQL Server, obviously, SQL database. It's a matured product. It's 40+ years of academic and industry research that have gone into that ecosystem. It's a highly evolved ecosystem with lots of tooling and community support. There's a lot of stuff there backing you within the SQL ecosystem that you can leverage if we build the graph functionality within that same ecosystem. We just extend it. It's used and trusted by millions of customers. You guys are all here. There's a lot of other SQL people in this conference. In a few weeks, there will be the PASS conference, which is exclusively SQL in Seattle. Millions of customers and enterprises, mission-critical workloads. It's a well-proven ecosystem. It's arguably the best database on the planet. So where else would we want to live? You can build your solutions on-prem, in the cloud, hybrid solutions. You get the best of both relational and graph database in a single platform. And that's the thing that I think is the biggest reason for doing this the way that we're doing this, is that you don't get a relational database and a graph database. You get a database that has relational data and graph data. So you can take advantage of that then. You may have a very rich data set that's correctly and properly expressed in relational tables, and you can join that with your graph data. So you use the graphs to find the relationships that may not be obvious and may be somewhat flexible, and then make that much richer by finding the deeper information that's held in the relational tables. So you have a much nicer, richer experience by being in the same ecosystem as all the relational data. And that's something that none of the other graph databases have done. They've had a separate enclave for their graph data, if they have any other data products at all. And it's backed by research. We've done a lot of research in the developing of this. There's a whole Microsoft research organization that we've worked with very closely. A lot of other researchers that we've used when we've developed this technology. So, SQL Server 2017 has graph extensions. So graph is a collection of node and edge tables. To support that, we have language extensions. We have DDL extensions for create node and edge tables, and query language extensions. We have a new built-in match that supports the pattern matching and traversals, the new syntax that we have for that. And we'll give you concrete examples of what that looks like and how it works. Tooling and ecosystem, that's all engaged. So the current version of Management Studio, you know that Management Studio is now shipping independently of SQL Server. So the shipping version of Management Studio, which is 17.2, has the graph stuff all implemented in it as well. So IntelliSense recognizes it, all that stuff works. DDL extensions. Nodes and edges are stored internally as tables. They have properties associated with the node and edge tables, so an edge table may or may not have any user-defined properties. We've talked about that. Indexes are fully supported on both nodes and edges. So if you need to find the data, you can get to it very efficiently. If you know that you're going to be keying on the nodes by a certain ID, you can put a clustered index on that. If you know you're going to be doing analytics across millions of nodes, you can put a column store on that. All those index types work because for the underlying engine, it's just a table. We've put intelligence on top of that table. So what does the syntax look like? So create node is a create table attendee, attendee ID, first name, last name, as node. And that keyword as node is what makes that table a node. And as you might guess, since it is created as a table, you can just join it with any other table. You can ignore the graph attributes, or you can embrace them and use that as part of your query as well. And select top 5 from attendee. Why not? So you have the node column, so that's a computed column, comes out in JSON format so that each of the entities has the type is a node, schema is DBO, table is attendee node, and the node ID is 3. Attendee ID was a unique identifier, so you've got that GUID there, attendee first name, and attendee last name. So this is what it looks like if you just look at the raw node and edge tables. And you could do whatever queries you wanted within pure T-SQL without leveraging the graph capabilities by just joining attendees, IDs, and looking for names. That all works. But we give you a richer set of semantics that you can leverage. Create edge, create attends, rating integer, so that's an example of adding a property within that relationship, edge. So you create the table as edge. Or you can just create table from as edge. Right? There's no data that we want to piggyback on that relationship, so we just create table from as edge. So that the parens with the list of columns there is purely optional. And this is what it looks like if you select top 5 from. So again, you have the JSON data for the edge ID, type is edge, DBO, schema DBO table from, and ID, 1920, whatever. Query language extensions. So how do you leverage this? How do you leverage all this richness I've been talking to you about? You have multi-hop navigation and join-free pattern matching using match predicate. Okay, that's a mouthful. Let's unpack that. There's a syntax that is called ASCII art. So you'll see right here is the key. So you have match So you have select attendee name as attendee name, session.session ID as session from attendee attends, so this is the edge, attendee, it's a node, and session, it's another node. Where match, so the attendee attends a session, all right? And the session.session name equals graph extensions to Microsoft SQL Server, this session. So what this will get you is from all the people at Ignite and all the sessions that they attended, this will get you the set of people, the names and the session names, the set of people that attended this session, or at least registered for it. That's a very simple way to express what would take a lot more T-SQL without the graph extensions. And it's a very intuitive attendee attend session. That's pretty intuitive what we're doing there. It's integrated into the engine, so this is what it looks like in Management Studio. You have your tables, and within that, there's file tables, external tables, graph tables. It's another special case set of tables. And if you see, helps to grab the right mouse. See, this table image has two circles linked. That's an edge, because that's what edges do. And this has a big circle. That's a node. So this is how you see the node and edge tables depicted in Management Studio. You can go into that, drill into that, and see all the different attributes. I'll show you that live in a bit. Existing tooling all works out of the box. SSMS, backup, restore, import, export, all that just works because it's just part of SQL and it works. Queries can join existing tables and graph, node and edge tables. Column store indexes, machine learning, R, Python, HA, etc. just works. So you can now start extracting lots of rich value out of all these relationships that we're expressing within the graph ecosystem. Security and compliance, dynamic data masking, row-level security, always encrypted. Again, it's a table. Everything you can do with a table, you can do with a node or an edge. You can just do more. It's available on SQL Server on Linux as well, of course, because SQL Server on Linux is SQL Server. It is not any form of subset because it's all built from the same code. And that's a topic I really want to hammer home, make sure that it lands, is that when we build SQL Server, there is only one code tree. There's not a separate code tree for the different deployments. We build the same code tree, and you may deploy it in your enterprise with an enterprise license key, and you get a certain set of functionality. You deploy it with standard, and you get a slightly different set of functionality. We deploy it in the cloud, it gets tuned slightly differently, but it's all the same bits. And that's why you'll see the functionality appearing across the boards. Linux builds from all the same bits as well. So it's really a value to have all that common code base. About once a month, we drop new bits into Azure. You'll see them light up. And once a year, you'll see new releases of SQL Server on premise, give or take. I think it was 14 months this time. So let's go back and look at what we've done. So this is what it took to do the basic reservation query with T-SQL. And probably most of the people in this room could write that query, but it's going to take you some time and thought. Or it can condense down into that. And I'd argue that this is both much simpler, much more intuitive to understand what it's doing, as well as much more flexible. So let's look at what we've got here. So this match clause starts here. So you're looking for attendees that attended this session. And this session is session ID 101. So you're looking for other people that attended session ID 101. So you get the set of attendees that attended this session, and then you take that set and find the other sessions that those people attended, and those are your set of recommended sessions. And then you add the extra qualifiers on that the session names in the recommended session shouldn't be this one, because it would be silly to say, based on this session, let's recommend this session, obviously. And attendee ID is not the same as the person that's doing this, so you want to see what other people looked at. You know what other sessions you signed up for, right? You don't need to know that. You need to know what other people are interested in. And then you have group by session name and then order by count. So you're looking at how many people recommended each session and getting the top 10 out of that. So it's a fairly straightforward query. So now I have a demo. So we're going to run a simple match query to see how it works. So this is select attendee.attendee name, session.session name from attendee and session with attends. So you've got the two nodes and the edge where you have a match of attendee, attend session. So this is every session that everyone attended. It timed out, so I need to reconnect. That's better. So, just that quick, we've got a list of the sessions and the attendees that attended them. Okay, that's interesting. Let's see what else we can do to refine that. So our user, Jimmy, has attended upgrading to SQL Server 2017. Now he's wondering what other sessions to attend, and the recommendation query is going to tell him what other sessions the people that attended this session are going to. So you have the top 10 recommended sessions, that session name. This is the session, the example that we've been looking through for a while. So the two sessions that come up are graph extensions for Microsoft SQL Server with 134 recommendations, and SQL Server on Linux, availability and disaster recovery. So that's the example you get out of that. And finally, because this is a fairly flexible system, we've gotten an ecosystem or a system that we tune for doing recommendations, but what other insights can we get out of that? Jimmy has attended a bunch of different sessions, and now he wants to know who else attended those sessions so he can reach out on Yammer or Twitter and connect with other people that have interests in the things that he's interested in. So now he's going to look at, find the attendee name, session name, from attendee, session 1, and attends. So you're doing the match where attendee attends session. So attendee.attendee name is Jimmy Harmson. So all the sessions that Jimmy Harmson attended and other attendees attended. So you're finding all the other attendees that attended the same set of sessions that Jimmy attended. And there you have it. So Jimmy and all these other people all attended upgrading to SQL Server and graph extensions. Okay. We will be carving out time at the end for questions. Graph questions we found tend to get fairly deep and can go a long ways, and we want to get all the material out there. We will reserve time at the end for you to ask all the questions you want, and we'll move out in the hall after that, so we'll get answered. So relational versus graph. Graph and relational designs can't answer the same questions. We've shown that. We've shown you what the relational query looks like to answer that question. We've shown you what the graph query looks like to answer that question. If traversal of a relationship defines the primary application requirements, that's when graph can solve it more intuitively and with less code. So if the primary purpose here is looking at relationship between objects and entities, that's where graph shines. If you're just looking at straight, static, hierarchical data, you might as well go relational. It's familiar. What are the different scenarios for graph? Common graph database scenarios, recommendation systems. We've gone through that here, right? You can see how graphs make that scenario much simpler, much more intuitive, much more powerful. Fraud detection. This is actually in use in a number of places where they're using this to find relationships that might not be obvious, then can help with fraud detection. For example, you may have information that Mary had access to a bunch of credit card numbers as part of her job, and Jim fraudulently used a credit card number over in this location here, and you would never connect those two people unless you knew that both Jimmy and Mary went to the same gym every day and hung out together. So those are the sorts of relationships that might not be obvious until you start doing that, and this is actually the kind of scenarios that are used to do fraud detection these days, to go the extra levels deep to find not the single person that committed the fraud, but also the rest of the ring. So you can get the whole picture rather than just a tiny piece of the picture. Content management is very useful in content management, finding all the relationships between a complex set of content. Bill of materials, product hierarchy, CRM. If anybody was at Rohan's talk, he had the dynamic CRM people talking about how they're embracing graph in that product and how it's benefiting them. So we're going to focus for just a bit on content management, and I'm going to ask Alex to step up and tell his story.
Awesome. Thank you, Kevin. So is it fair to say that SQL is not only a relational database, but a relationship database?
Absolutely.
Yeah, I should be in marketing. Hello, everyone. I'm Alex Shiba, so I work for Sitecore. Can I get a quick show of hands who heard about Sitecore before? Sitecore people don't count. Just a few. Any of you guys using Sitecore in your daily job? No? No? One? Okay, tough crowd, okay. Well, this gives me an opportunity to tell a little bit about what we do, because as any tech company, we are evolving and moving into new exciting markets. So I pretty much do what every engineer dreams about. My job is to build cool stuff, play with cool technologies, and not be responsible for shipping anything, right? Well, last part is partially true. You gotta ship something. So my team got access to some early bits on SQL Preview, and we had a chance to play with it, apply it to some core platform scenarios that are a little bit boring but important, and also some public-facing, more like juicy customer experience scenarios. What can we do with Graph to enhance and delight customers in the front end? So that's exactly what I want to show you, how to take this scenario that Kevin went through and apply it kind of soup to nuts, so to speak, and see how they go. So I have an interactive demo at the end. If demo gods are playing nicely, my machine randomly rebooted earlier, so I hope this was it. This was just a test call. So I hope this works. Before I go there, let me just quickly talk a little bit about what we do, because I think it's pretty cool. We started in 2001 as a content management company. That's our roots, and that's what kind of differentiates us among other competitors, kind of in a more from historic perspective. And we're a market leader in that capability, and that evolved into what we call experience management. It's a capability that's not only able to solve content management needs, content creation, publishing, workflow, that sort of thing, but also distribution, delivery of that content on a global scale, planet-wide, for global brands, multilingual, multi-brand, stuff like that. So it's, there's a lot of power in there. It's, again, that's our heritage. Currently, we're able to kind of detach from the web channel, traditional websites, so we can power content on mobile device, email, etc., any channel. What's less known is that we also have a digital marketing platform, which provides a marketer with ability to collect, analyze, and act on every single interaction your customers have with your brand. And that gives ability not only to understand, analyze, but also predict the next best action for your customer. So as you can imagine, there is a lot of richness in that data. There is also even less known capability, which is commerce. This is a brand new commerce engine that we rebuilt in .NET Core and the microservices architecture. So it's really state-of-the-art stuff. And what this does is pretty much extends this experience platform capability. So brands have access not only to content, customer and their behavior, but also to transactions, right? And what that gives them ability is to manage effectively their online shopping experience. So as I mentioned, we all built on .NET from pretty much day one, and we kind of continue consuming lots of Microsoft goodness, including Azure, SQL, and .NET, including brand new .NET Core platform. The whole mission of the company is to help our customers, brands, to develop relationships with their customers for life, and revolutionize this relationship that sometimes is kind of one-way street. So, and we talk about context marketing a lot. What that means is that we would like to empower meaningful quality conversations that brands have with their customers. What does that mean? What does experience mean? You probably heard the word experience a lot. It's very subjective. The way I think about it, I know what bad experience is. And one of the stories that my colleague told me that kind of resonated with me, that kind of put everything in perspective, is that he got an email offer from a top hardware company with an offer for his smartphone, which shall remain nameless. But he purchased the smartphone 2 weeks ago. So that wasn't cool, right? And we're talking about top brands making these seemingly obvious mistakes, right? It's not cool. It should be probably illegal in certain states to treat customers that way. And people expect better, right? So that's what Sitecore's its mission to do, is to help brands understand full 360-degree view of the customer and target meaningful conversations on different channels. The central piece of this capability is what we call experience database. And that's something that is able to collect, analyze, and you'll be able to act on every single interaction customers have with your digital property, right? Whether it's a website, mobile app, it doesn't really matter. So at this point, you can imagine there is so much richness in that data in there. There is tons of relationships between customers, what they do, how they do it. So the idea is like, it's natural to funnel all that data into the graph and see what we can come out of that. So what we're gonna do here, we're gonna do something a little bit stupid. We're gonna apply all of these powerful, quite expensive technologies to build a conference website. So what that gives me ability is to show how this scenario is coming to life, right? Where we have a conference website and we'd like to go beyond just static content, right? We would like to provide recommendations right there So folks don't have to go and click through agenda and just have it populated automatically based on recommendations that Kevin was showing. So how do you do that? Well, we take all this SQL Graph capability, but we need data. So the data, this is just an example of how you could put it together based on technologies you have. So I'm not saying, oh, you have to use Sitecore. This is just an example because we have strong foundation in content. It's easy. Model your speaker session content right there in the system. Have web UI built out for this website. That's all handled. That's kind of table stakes. But there's also behavior, right? So you can collect behavior about sessions, which are attendees attending, speakers that they follow. You can hook up to LinkedIn connector and capture some of the basic profile. This is all plug and play, really. And all of this data can be funneled right into SQL Graph. So we can model our core domain, which is the most exciting part of our graph databases, really. And using all the standard features, let's see how we can kind of put it all together. So just a reminder, this is the graph database with graph model we're talking about. So the data is coming from multiple places, which is pretty much a norm these days, right? So we have LinkedIn powering industry location. It's part of their basic profile that you have access to when you set up any connector. That data is pushed into Experience database first, and then funneled into Graph, SQL Graph. We also have speaker information, and we're capturing these events of attendees following a speaker. We're capturing this as a behavioral information. And another one, we able to track which attendees attending which sessions. It's just an event that's fired every time you click attend. And we have a more of explicit information about speakers and which sessions they're attending. Very basic graph model. So what we want to get out of this is two types of recommendations. One is, let's suggest other attendees to meet. Let's be a little bit more social. So maybe we can suggest folks from the same industry, same location, attending same sessions. We'll score it, we'll order it, and suggest you tell people for you to meet. Why not? Another type of recommendation, which is also a pretty basic one, but quite powerful, is let's suggest sessions based on speakers that they follow, based on which sessions are being attended by other attendees in the same industry. Again, no rocket science here. And in reality, this graph model can grow. And I like this elasticity of this approach because you can augment your graph model without rewriting a bunch of code. Right, so in reality, we can bring in information about topics, tracks, interests. We can also connect speakers and their LinkedIn profile with our nodes, industry, and location that are already there. Hell, we can bring even the whole LinkedIn graph into this if we feel like it, right? Ability to see what folks that you connected with sessions they're attending, and factoring that into our recommendation query. We can connect it to Office 365 graph. I mean, there's a ton of opportunities you have. You probably have that data somewhere, and it's available. Maybe it's already in SQL. So reality that it's a bit more complex, but we'll focus on the basics. So let me show you a demo of how this whole thing is put together. Put together using Sitecore's tools with SQL Graph. So I got this site published out, and this is a short URL. It's right on Azure, so if you'd like to follow me, there will be a cool benefit at the end. So it's sitecoreco.re/graph demo. So let me open it up and walk you through this experience. This is a very innovative design that I'm using here for this site called Bootstrap. And this is anonymous experience on the site. So here you're presented with login button, with my homemade legal disclaimer right there. So I'm not planning on sending you guys emails after this. So your data is safe. So anonymous experience is standard. There's static data. I can go and look up and add maybe some sessions to my agenda, standard stuff. So this is whole thing Sitecore is running this thing, right? There's nothing GraphQL, graph database going on here. I can favorite my speakers, but if you go into recommendation section, this is something, actually I have it. Let me open it up. There's some session sharing going on here with Chrome. So the default experience is that we cannot show you any recommendations because you're not signed in, right? So let me show you the experience when you signed in. It's the same site. I'm just gonna use Chrome because Chrome remembered my login session, so it identifies me. So now because I have some data right there, I can have access to these sessions right here in the recommendation section. So what it does, it's already hooked up to a stored proc, so there is some API that's built out, so it executes the stored procedure that Kevin was showing. So really nothing super interesting here. This is just a flat list of sessions and people. Now there's a hanging node there. I deleted myself before the demo didn't clean up completely. And here I have Kunshrey and Todd here sorted by the weight that I have defined in my query, which I'll show you in a second. But wouldn't it be nice to have a little bit more graphical? Because it's graph, right? Wouldn't it be nice to have actually a visual representation of my connections? So my circle around that shows people in this room or in this conference I am connecting to, so we can actually bring graph onto the surface with visualization. So this is what I'm going to do. I'm going to do something completely obnoxious here. I'm going to deploy this SQL statement right into production, right into SQL Azure. So this modifies existing stored procedure, meaning that the whole plumbing is already pre-set up. So I already have API that powers that visualization, brings data from this stored procedure. All I need is kind of meat on the bone. So here we're selecting folks from the same industry, and we're adding this artificial score of 5. We're saying that people from the same industry, that's weighted higher than all the other relationships. I can actually store it on my edge if I wanted to. Here, I just wanted to have a little bit more programmatic flexibility. And I'm also returning this via this just labeled relationship that will help me visualize how do I connect with other folks in the conference. Here, I'm selecting same location using the match sequence, match syntax, pretty straightforward here. Attendees to attendees connecting through from with the same location node. I mean, it cannot be easier than this, and I'm not a SQL guy, right? And finally, we'll select each session, and we'll score each session with 1 because we probably have, it's not as important to have a single session in common than maybe being from the same industry. So this is completely random. As you can see, this is just an example. So, but let me run it. This deployed this change into Azure, and then I should be able to see now data. This is obviously hooked up. Now it's actually executing this query, and I have folks. Thank you for logging in. So I have some new folks joining, and I'm able to visualize that hanging node. That was me. I deleted my duplicate node from there, so it's still hanging on the visualization, which makes it funny. So the visualization is done in D3.js, which is just amazing JavaScript library that has all sorts of data visualization layouts. And one of them is this force-directed layout, which runs particle simulation, runs a bunch of physics algorithms here to kind of gives you this cool effects. So what I can do, I can drag here and I can see through which connections I'm connected with Shreya, with industry and sessions. Dylan, we connected with location. And with Alexander, we connected via, let me see, Try the same thing. Let's try to break it, yeah. Yeah, there was something hanging here, some bad code. So the thickness also, I mean, this is just data visuals, is a little bit out of scope of SQL, but you can encode visualization in different ways. So the length, the proximity identifies how many relationship links, common edges we have. So with Kun, we have quite a few. Let me reload it, it's a bit glitchy. And the thickness will also identify the amount of common relationships we have. So there you go. So we're attending 2 sessions, same sessions, and we're from the same industry. So that's based on my activities prior to that, when I went into sessions and I say, okay, I'm attending this session. And this is how recommendation algorithm picked it up. So very basic stuff. This is really maybe a couple of days of work. You probably have systems already in your enterprise where you have a bunch of data, it's rich with relationships. And especially if it's in SQL, ability to sort of connect these dots becomes really, really an easy task. And it was quite enjoyable to do it. We have Konstantin joining as well without a picture. Maybe it's a bug in this JavaScript code. Right, so that was the demo. My intent was to show you kind of how things could connect, how you can actually go from lower database level down to kind of UI level, and using pretty much the system that's able to reuse data. Let me go back into the 5. Go back to the slides and finish off with probably the elephant in the room question. Preemptively answer the question why SQL Graph over hundreds of other graph databases. It's a little bit of exaggeration, but if you count all of the open source graph databases that are born every week, probably there's over 100. Official list is a bit less than that. Well, first of all, of course, it's the ecosystem, right? It's both for us as a software vendor that is based on Microsoft technologies, it just makes sense. Our investment in SQL and our customers and partners' investment as well. As you know, bringing foreign entity into ecosystem, it's expensive, it's hard, it's a conversation you don't want to have as a vendor. It's also the familiarity from perspective of just its use, where we can use existing tools and skill sets, and there is no surprises because you know it's SQL, you know what to expect. The flexibility in terms of models, when there's a relationship and graph model you can use and combine it in a more effective way, that's great. I mean, the more flexibility, the better. And also flexibility of deployment. Targeting both on-prem, for some scenarios, we still have those. And as we have more customers migrating towards Azure PaaS, we have that feature there already, and it's the same code. So it kind of becomes no-brainer. And speaking of cloud, because it's released in GA even before it hits on-prem, then there's actually less and less reasons not to use it. And for you, because it's already there should be no reason for you not to use it today. So I want to leave it at that, and would like to thank you. If you have any questions about how this whole demo was put together and about Sitecore, feel free to catch me after. I'll turn it over to Kun. He will show a little bit more in-depth best practices with customers he had at Microsoft CAT. Kun, take it away.
Good. Thank you.
Sure.
All right, that's a cool demo. My name is Kun Chen. I'm also with Microsoft. Actually, I'm Kevin's colleague, but I'm focusing on Azure SQL database. Actually, I work with a lot of customers and partners. I'm hoping actually I can run into some of you in this conference. The team I'm working in is called Customer Advisory Team, so maybe people knows CAD or Customer Advisory Team. Come talk to me. But anyway, so just want to share some of the best practices, the learnings we got from the past engagements over the last year or so, since we shipped the graph. The first scenario I want to talk about is about the data loading. So as I can see, we're trying to integrate the graph into the SQL database. Now, you need to have the data, right, in order for you to do any processing or graphing. Especially for some enterprise customers, they need to have a large amount of data load into the database in the SQL database itself, either in the SQL Server or on Azure SQL database, there are some common techniques you need to be aware of. How do you efficiently load large amount of data in the fastest fashion, right? For Azure SQL database today, we support BCP, bulk insert, right? Different methods. And you probably know SQL Data Warehouse. If you attended the previous session, there's a polybase, right? Which can load the data into multiple computer nodes. But today, for SQL Server or Azure SQL database, you can simulate multiple threads, but they're all going to be loaded into the same instance of SQL Server. Now, this technique applies to general loading, not just for the graph data, right? So when you load the data, you want to make sure you disable all the indexes on the table. In this case, if it's a graph table, you want to disable these indexes as well. Because when you create the graph table, by default, you already have index, right? Either node or age tables. You want to make sure if you want to load the data as fast as possible in the graph tables or age tables, make sure you disable these indexes first, okay? And then once you load the data, you can recreate or re-enable indexes, or you can re-enable, recreate the indexes as you wish. One thing I want to point out is, as Kevin and Alex were pointing out, you can use columns not indexes on the graph tables, right? Columns not indexes also need to be disabled, right? If you load data, loading into the heap is much faster than loading into a table with any indexes, including column store indexes. So it's very important for you to remember that. On the other hand, I have run into a scenario where customer maybe want to leverage the compression of the columns or indexes so they can minimize the space of database, especially on Azure. We have the space limits for particular service tier performance level, right? For example, if you're loading the data into S1 or S2, we give you 250 gig, right? If you go to P1, we give 1 terabytes. If you go to P11 or P15, you get 4 terabytes, et cetera, et cetera. We had actually customer that want to load the data into the P1. They're also using columns or index, and at the maximum, you can get 1 terabytes. So when they load the data, they actually can load much more than 1 terabytes because they can use the columns or indexes. So they keep the columns index in place and load the data into that P1 database, right? So a little bit slower, but at least you can get all the data in, right? So you have to do the trade-off, the balance between if you want to achieve the best loading time versus if you want to get more data into the database. So we talked about this common scenario, but I just want to switch gear, talking about a different scenario, using graph, very simple graph database with the three nodes, person, dog, and cat, and a single age called likes, right? So I have only 2 rows. So for example, I have Alice and Bob. Alice likes dog only, and Bob likes both dog and cat, right? It's a very simple graph relationship. What I'm showing you here is, a common question people are going to ask is about, what about if you want to find a person who likes dogs but not cats, right? In this case, it should be Alice. If you're using the graph, the match clause here, right? You can see it's a common, it's very intuitive. You have a match. I'm going to use the match, the person who likes dog, but not matching the same person who likes a cat. If you try this today, actually it's not going to work. You're going to get this error message, yeah? Unfortunately. So just remember there's some, for the match clause does not support all or not in this case. The reason actually, I believe we use the support as a match clause in this, not a match clause, but actually you're getting incorrect results. That's why we disable this, this scenario. You cannot use a not-match. Instead, you can use this syntax, right? We still keep the match. Find the person who likes dog, but that person does not exist in the results of the subquery. The subquery basically trying to find the person who likes a cat, okay? So this is a very common scenario for people to misuse the match, but you can use this particular syntax scenario to achieve the same purpose. Another best practice or learnings we had, was based on some complex query joins. So the principle here is, the way we design the graph or the optimizer is all these intermediate node tables in the match predicates can be optimized out if they're not showing up in your select or where clause, okay? So I'll give you a sample query. In this case, I have the user table. Basically, I'm trying to find, get all this user, the user ID concatenated as a friend path. There's a friendship between all these users. And you can see, well, this is basically, I have to select all the users and find the relationship between all of them, right? So you can see all these intermediate nodes in there. Unfortunately, because actually, if I don't really care about this like an intermediate, like this user 2, user 3, user 4, if I only care about the first user and the last user, and find out if there's a friendly relationship between the two, I can rewrite the query simply as like just concat the first user and U5. In this case, because all the age tables have the information about all this, the user U2, user 2, user 3, user 4, etc., etc., the optimizer can just get out of this, kick out all these intermediate nodes from the query plan. We can speed up the performance of this type of query. Make sense? As of today, so there are some of those limitations in the graph. This is the V1 of the graph, right? So some of the native feature, built-in features, not quite there yet. One of the things is, a very common scenario is from customers who trying to find the shortest path, either between, two nodes or from one node to all the other reachable nodes, right? How do you come up with the shortest the path? It could be weighted. In this case, like say, I show the graph from like New York to San Francisco. I could have different paths, and each path maybe have a distance, which is kind of the weight. You have to keep in the calculation algorithm. We don't have a built-in function, in the graph database yet to support this type of scenario. What I'm showing here is the sample T-SQL. One of my colleagues put together. It's published on GitHub. It's based on the, I think it's based on the Yelp database. So if you want to use that sample, you can give it a try, but just make sure you respect their policy. I don't think they want to share this data in a commercial way. But this will give you an example how you can find either shortest path or find either all paths from a given node to another node, or find the shortest path to all the other nodes. And the other one is just like, this is just either between two nodes or from one node to all the other nodes, right? Either from New York to all the other cities that can reach, you can fly to, or between New York and San Diego, for example, what's the shortest path. But I don't want to go into details given the time we have, but you're welcome to explore. I believe my colleague put in like 4 different approaches on how you can find those, the shortest path between nodes. The last but not least is the topological sort, right? So I'm not sure how many people in this room are kind of database or DBA background, but one of the common things is trying to find, hey, if I have a bunch of tables, have a fairly complex database schema design, if I want to, all the tables have the foreign key relationship between them, right? If you want to drop a table, which happens to have a foreign key relationship of a bunch of other dependent tables, and those may have other foreign keys between them, right? How do you find out which table I should drop first without getting that error message basically saying, you cannot drop that table, right? So this is also, you can use the graph to solve it, unfortunately, but there's no built-in function yet to tell you, like say, how do you list all dependencies between all these nodes in this graph database yet. Similarly, we have kind of a T-SQL workaround for you to use today. So I don't think we published anything yet, but if you really have a special interest, come talk to us, and we can share some of the T-SQL examples with you as well. So just remember, there are some limitations, but we do have T-SQL workarounds or equivalents existing out there. Okay, with that, I'm going to just hand back off to Kevin.
Thank you. So we've told you about what we've already delivered to you in the graph functionality. So how many people think this is pretty cool stuff? All right, that's what I want to see. You're all graph converts, and you're going to go write graph applications, right? At least play with it, please. So let's see what's next. We're not stopping. That's not what we do. So this will continue to be developed and enhanced as we go forward. The next things up on the list for enhancing graph shortest path and arbitrary length traversals. So what does that mean? If you've got a relationship, person likes person, you can use that same recursive relationship to go a lot of hops. So what we're going to enable you to do is find the shortest path from person A to person B, or to find the path from person A to person B with a specific number of hops. So find the path that's 5 hops from Shreya to me, or find something in between 1 and 10 hops between these two people. So that's an interesting way to look at the relationship. So how many hops is it between these two nodes? Find the friends 1 to 5 hops away. Heterogeneous associations. So this is where you're using an edge to connect different types of nodes. For example, with the likes edge, you may be connecting people to sessions or speakers. So this would be the ability to write a query that says, find the people or sessions that this person likes. It's because sometimes people will pick sessions based on the speaker, and sometimes they're looking for a particular topic. So this way you can find either topics or speakers or sessions. Language enhancements, we're adding the ability to use node and edge tables within merge DML. And edge constraints. So this is where you can limit the number of nodes that an edge will address. So you may have an edge that you only want applied to certain types of nodes. So Mary's would be another person, not the dog, right? So silly example, but this is what that technology does. So at that point, I'd like to open this up for questions. We've got about 10 minutes or so, and take all the questions you have, and thank you for your time.